Okay, so we're just going to do a really quick review of some factoring. So if, for example, we're looking at a question like our first one, right? We have 6a minus 3b. Whenever we're factoring something, whether it's a binomial or a trinomial, the first thing we always want to do is find that GCF, okay? And that's our greatest common factor. So what that means is we're looking for something that divides into both the first term and the second term. If it was a trinomial, it would have to divide into the third term as well. So something that works for all terms. So if we look at 6ab here, okay, if we look at our variables a and b, we can't find anything that divides out of both of those, except one, right? But we don't really count that. So we know we're not going to use any variables with our GCF. So if we look at, however, the 6 and the 3, we notice, okay, well, GCF, the greatest common factor of those is 3. That divides into both things. So what we're going to do is we're going to take a 3 out of this. So 6a divided by 3 gives us 2a. And then 3b divided by 3 gives us b. So that negative stays there, right? So we just get 3 times 2a minus b. Okay, so that's our kind of simple factoring problem that we'll often be dealing with in this course. Okay, they can get a little bit more complicated sometimes. So for example, if I'm looking at something like this one, right? So we'll go 9ab squared minus 3abc. Okay, so no matter the problem though, the first thing we always want to do is we always want to look for that GCF. Okay, so if we look at this, we say, okay, well, this time let's look at our numbers first. Okay, if we look at 9 and 3, the thing that we know that divides out of both of them is 3 again. Okay, and then we want to look at our variables. So in the first term, we have an a and a b squared. Okay, so we need something that's both in the first term and the second term. So if I look at the second term, I go, okay, sweet. There's an a in both of those. So a is definitely going to be part of my GCF. If I look at b, say, okay, well, there's one b here, but a b squared is actually like 2 b's, right? And I know it's got to be in both, so I'm just going to use one b in my GCF. If I look at this c here, I say, okay, well, there's no c in the first term, so I'm not going to include it. So I know my GCF goes in front. And then inside the brackets is everything that's left over after I've divided my GCF out. Okay, so 9 divided by 3 gives me 3. A divided by a, that cancels them out. B squared divided by b gives me 1b left. Okay, so that's my first term. My second term, I'm going to go 3 divided by 3, so that just leaves me a 1. And we don't usually write 1s, right? So I'm just going to leave it for now. And then I have a divided by a, so that one looks good. B divided by b, so that cancels out. And then c. Okay, so all I have is one c there. And I can write the one if I want, but we don't usually, right? So for my answer, I have 3ab multiplied by 3b minus c. Okay. The other type of factoring problem that we're going to be looking at tonight, or today I guess, is our difference of perfect squares, right? So difference of squares. Okay. And this is where we have something like this form. It's going to be one perfect square minus another perfect square. And sometimes they're really easy to spot. Like, for example, we have x squared minus 9. Okay, we know that's nice and easy to spot, but sometimes they're a little bit more difficult. So the rule is that we want to take the square root of the first term and the second term, and we're going to put them in separate brackets, and one will be a positive and one will be a minus. Okay, so if we had x squared minus 9, we'd say, okay, that's like x plus 3 and x minus 3, right? Because when I look at this, I say, okay, the square root of x squared is x, square root of 9 is 3. Okay, so when I look at this, that x goes there, and there. And then say, for example, if I'm looking at the 3 goes there and there. Okay? Nice and straightforward. Sometimes, however, though, they are a little bit more difficult to see. So, for example, if I'm doing something maybe like, what's a good one? 121 p squared minus 9 q squared. Okay? We have to be really careful and really recognize that, okay, this is a perfect square and this is a perfect square. And we have to pay attention because not only do I need the variable to be a perfect square, but I also need the coefficient, the number in front, to be a perfect square. Okay, so same thing. I'm going to look at this, and I'm going to say, okay, the square root of 121 is 11. So I know I'm going to have 11p, then the square root of 9 is 3. So 11p minus 3q and 11p plus 3q. Okay, so they're nice and straightforward once you see them, but sometimes they're kind of tough to see, which is the hard part about them. Okay, so that's our quick 6-minute review on factoring.